Hello everyone, let's solve the problem find duplicate subtrees. So, given the root of a binary tree, return all duplicate subtrees. For each kind of duplicate subtrees, you only need to return the root node of any one of them. Two trees are duplicate if they have the same structure with the same node values. Let's see an example. We have this subtree. This 2 and its left child 4 along with this 2 and its left child 4, they are duplicates, right? Therefore, we have to return this any one of them, that is 2. Similarly, if we go down, we can see that this 4, this 4 and this 4, this single nodes itself, they are duplicates. They are 3 in number, right? Therefore, this is going to be another candidate of our answer. Note the thing that this 2 and 4 and this 2 and 4, they are structurally same, right? This 2 is the parent node and 4 is its left child. Similarly, for this one, 2 is the parent, 4 is the left child, right? Had it been the case that 4 was the right child of 2, it wouldn't be a duplicate, right? They have to be exactly same. Okay, let's see this example. 2 1 2 1. This 2 1 and 2 1 can't be a duplicate because they're structurally different, but this single node 1 and 1 are duplicates, right? Because to the left of 1 we have null, to the right of 1 we have null. Similarly for this, null null, right? So they are structurally same. Now let's see this one. 2 2 3 and 2 3. These two circled subtrees are right same, right? To the left of 2 lies 3. Similarly here 3 is the left of 2 and to the right of 2 there is null, right? So they are duplicates, so we return this one. Also, if we see, if we go down, this 3 and this 3, they are also structurally same, right? If 3 is the parent, both the children are null, right? So one thing to be observed is that if this is our subtree and if they are duplicates, then their children will also be duplicates, right? Similarly in this case also, these two are duplicates. Similarly their children are also duplicates, right? Now we are supposed to find duplicate subtrees, right? And in order for that, we definitely have to traverse our tree, right? Now we have been set to find the duplicate subtrees which have the same structure. Okay, let's say we do a breadth search traversal. Okay, is that going to help us? No, because in breadth search we go level by level. Okay, we are not looking at the structure, right? But in the question we have been said that our structure needs to be same. So for that purpose we are going to perform a DFS, that is, it will go this side, then this, then again this side, right? This is the structure, this is the structure, right? So for that purpose we are going to use a DFS. Now the thing is, two given subtrees will be same if their structures are same, right? And in the structures, if their node values are also same, then they would be duplicates, right? Therefore for that purpose we need to create our structure, right? When we traverse our tree, the subtrees that we are traversing, we need to record their structure, right? What do I mean by structure? Let's see, our root node is 1, then at the left we have a 2, at the left we have a 4, then left is done, then we have a null, right? Our left subtree is done. Then to the right we have a 3, to the left of 3 we have a 2, to the left of 2 we have a 4, then to the right of 2 we have a null, then to the right of 3 we have a 4. So this is the traversal of our this tree. Now what is this traversal exactly? What have we done here? This is the root node, this is the left subtree of root node, and this is the right subtree of our root node. Then for this one, this is the left and this is the right. For 3, this is the left and this is the right. For this 2, this is the left and this is the right. We can clearly see that it's a pre-ordered traversal, right? And by this we have actually recorded the structure of our tree, right? Similarly for this subtree 2 and 4, this is the structure. Left of 2 we have a 4, to the right we have a null, right? For this subtree, this one, the structure is something like 3, to the left we have 2 4 and null, to the right we have 4. So this is what I mean by structure. Now how are we going to find if there are duplicates, right? Say we encountered this structure or this subtree, okay, 2 4 and null, that is, say this one. Okay, we will store it somewhere. Okay, fine, we stored it somewhere. Now when we come to this subtree, we are again going to have this same structure. 2 to the left we have a 4, to the right we have a null, and we will see that in the data structure we have already stored this structure. That means this same subtree with same structure and node values was encountered before as well. That means this is a duplicate, right? And in that case we will add it to our answer list. Okay, now which data structure are we going to use for this purpose? We are going to use a hash map. Okay, how will it help us? We will store this structure in our hash map. We will store this structure in our hash map. Okay, when we encounter this, its count increases to 1. When we encounter this again, its count increases to 2. And as soon as our count increases to 2, we know that there exists a duplicate of this subtree, and in that case we add it to our answer array. There can be more, right? Like as we saw in this example, we have 4, 4 and 4, right? But that doesn't matter. As soon as we have found 2, at least 2, that means we have a duplicate, we right away add it to our answer. Okay, now for this tree, let us create the structure of the rest of the subtrees. This is our whole tree, right? Now let's look at the other subtrees. We have 2 and 4, that is 2 to the left we have a 4, to the right we have a null. Okay, this is 1. How many times? It's 1. For this one we have encountered it 1 time, right? Okay, now we go to right, we encountered 3. Okay, what is this subtree? It's 3. To the left we have 2, to the left of 2 we have 4, to the right of 2 we have a null, right? This one is, this side is, left side is done. To the right of 3 we have a 4. Okay, done. We encountered it 1 time. Okay, this is the left child, this is the right child, this is the left child, and this is the right child. Okay, for this one this is the left, this is the right. Okay, now let's go deeper. For this one we have a 2 and a 4. 2 to the left of 2 we have a 4, to the right of 2 we have a null. Left subtree, right subtree. Okay, now this one is already present here, right? So this frequency gets increased to 2. Fine. Okay, let's go deeper. We have a 4. To the left of 4 we have nothing, to the right of 4 we have nothing. Let's write null null, or let's leave it as 4 only. Its frequency is 1. Here we can see we have another 4, right? Frequency increased to 2. Also we already had one more 4 here, right? We missed it, so the frequency is going to be 3. So what is our answer array going to contain? Our answer array is going to contain 2 comma 4 comma null and a 4. So what are we doing? For each subtree we are creating this structure. Let's say this structure is in the form of a string. Okay, we are creating this string of our tree structure, and we are storing its frequency in the map, right? And we will have an answer array. Okay, if our root is null, we will return, say, a string, say n or null, anyone is fine. Otherwise what we will do, we will create strings for our left and right subtrees. Okay, after creating that, we have got our children subtrees, right? Now we will create our current node structure, that is, which will have our current node, that is, say, 1. Then what is at our left? We have this, and at the right we have this, say, left plus right. Okay, let's call this one root. Also, one more thing that we will do is we will separate them using commas. Okay, otherwise it would be hard to differentiate, right? Like we have, let's say we have 1, 2 and 3. Okay, this we can differentiate, right? That at the left of 1 we have a 2, at the right we have a 3. Otherwise if we write 1, 2, 3, how are we going to interpret, right? There can be a single node whose value is 1, 2, 3. We can have a node which is 12, to the left lies a 3, right? And another is this one, so it would be hard to differentiate, so we will separate them using commas. Okay, now let us code our solution. We are going to need a hash map. right? Map of what? String and integer. Our string is going to be the structure and the integer is going to be the count, right? The number of times we have encountered that structure. New hash map. And also we are going to need our answer list. Let's call it answer. New array list, declaring them globally so that we don't need to pass them in our methods. Okay, now we will call our, let's say our method is DFS on the root node, and then we will return our answer list. Okay, now let's write the DFS. It will have a return type of string, DFS tree node root. Okay, now what did we discuss? What is our base case? If we encounter a node which is null, if our root is null, then we will return a n, or say null. Let's return a null, separate using commas. Okay, fine. Otherwise we will go to our left subtree and record its structure, right? DFS root dot left. Okay, then we will go to right and record our structure, root dot right. Now that we have the structure of the left subtree and the right subtree, we will now form the structure of our current subtree. Okay, including our current node, right? That is string current equals to root dot val plus separate using commas plus left plus right. Okay, then what we will do, we will put this in our hash map. What this will do, it will put this string in our hash map. If it didn't exist initially, we will it will return a 0, right? And then to it we will add a 1, so our mapping would be something like current comma 1, right? Or if it already existed, then it will get us the frequency, existing frequency, and to that we will add this 1. Say our frequency was 1, and to that we will add another 1, our frequency becomes 2, right? So if our frequency becomes 2, we now know that a duplicate exists. We don't care if more than 2 duplicates exist or not. We don't care about it, right? Because two same subtrees are enough to tell us if duplicates exists or not. So in that case we will right away add this subtree to our answer list. Okay, and then this string current that we have created, we will return it, return cur. We are returning this because it will be utilized, right, when we will backtrack, isn't it? Because we are calling this left on the left and on the right, right? So it has to return something, right? So it will return the string that will be found down below. Okay, so let's try to run it. Let's submit. Cool. Now what is the time complexity? The time complexity is, in order to traverse our tree, it's a big O of n, and for each traversal we are building a string, right, of at max maximum length that can be n. So our time complexity is O of n square. And what about the space? We are creating a hash map that will contain at max n strings, right? N, and each of the strings can be at max of size length n, so that is another n. Therefore space complexity is also n square. Okay, so I hope it's clear. If you have any doubt, you can ask me in the comment section. All right, so this is pretty much about this problem. If you like this video, do hit the like button, share this video and subscribe to my channel if you haven't, and I will see you in the next video. Bye bye.